we are going to discuss one among the important topics in your class 11. That is trigonometry. Now, trigonometry is not a new topic to you. You have studied something in your class 10th. You have something to do with this trigonometry in class 10. So in class 10, what you have discussed was the angles. There was a condition for the angles, definitely. It was all acute angles. So the relationship between the acute angles and the identities of trigonometry, that was what you had discussed in your class 10th. Okay, so here in class 11, we are going to deal with more topics on trigonometric ratios. Now here, trigonometric ratios, there in 10th, it was confined to the acute angles only, but here we are going to discuss on more angles. Not only acute angles, but angles that falls in one complete cycle, that is a complete rotation for 360 degree and more. Okay, so before that, let's discuss on what is an angle. How do you mark an angle? An angle is marked inside the initial ray and the terminal ray. This is something that you have discussed in your class 6. So if I mark this as 30 degree, you know you will measure it from this initial ray to this ray to get the angle 30 degree between the initial ray and the terminal ray. So that was the angle. So this angle is something that is measured anti-clockwise. If it is measured in clockwise direction, that is, if something is measured in this form, clockwise direction, this angle will be the negative of the angle. And clockwise direction, the angle value will be negative of that angle, indicating that the measurement is now clockwise. So if it is anti-clockwise, it is positive. Clockwise, the angle is measured to be negative. Now here, you have measured the angle in degree measure. That means on a straight line, if you measure the complete angle, as I told earlier, a complete cycle gives you what? 360 degree. Now, what is this 360 degree? 360 degree, you have seen 360 degree, a complete cycle. You have seen it on a clock face, isn't it? On a clock face, the R angle goes 360 degree. The R angle goes 360 degree in clockwise direction. And when it sweeps one complete face of the clock, we say that it has gone 360 degree, right? How many minutes did it go? 60 minutes. 60 minutes. And thereby, the R angle will move how many degree? 1 degree. Okay, by 1 degree. So, I can write 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. This is a common notation which we use in our clock face, on the clock face. So, exactly the same as what when we discuss for degree measure. Now, we are going to discuss a new measure for the angle, that is the radian measure. Now, let's see what is a radian measure. Now, to discuss on radian measure, I have a unit circle. This is a unit circle. What is meant by a unit circle? Unit circle is a circle with radius 1 unit. Okay, 1 unit. And with an arc length of 1 unit again, the angle subtended here is 1 radian. I call this angle subtended here, I write it as theta here, and this is 1 radian measure. So 1 radian is the angle subtended by a unit circle when the arc length is 1 unit. When the arc length is 1 unit, the angle subtended at the center is 1 radian. Okay, now how did I get this? If you think of this, theta is equal to, I can say that it is L by R. L by R. What is L? The arc length. What is R? 1 unit, isn't it? So that it is 1 by 1, which is equal to 1 radian. 1 radian. Is this degree? No, it is not degree, but it is radian measure. Now, what is actually the radian measure means? The length of the arc is centimeters. The radius is centimeters. Now, considering the right hand side of this equation, here if I take theta as a degree measure, can I equate a degree measure with a unit centimeter? No. So, in order to have a equivalence with the centimeter measure or the measures that we conventionally use with angles, we need what? A radian measure. A radian measure, not the degree measure. So this is what the meaning of radian. Now suppose that you have a circle, the unit circle with radius 1, and I take 1.5 measure for the arc length. Then 1.5 measure for the arc length. What will be the angle theta that is formed in the center? That will be theta is equal to L by R. What is L by R? 1.5 by 1. That is 1.5 radian. This measure is going to be 1.5 radian. Right? So I can see that this measure, angle theta, which corresponds to the length of the arc by the radius. Right? The length of the arc by the radius gives you what? Theta. Now here, if you remember, in the degree measure, I told that one complete revolution was 360 degree. You remember that? One complete revolution was 360 degree. Now, when it comes here, it is a circle. This is again the circle. So, what is the angle of theta that falls here? That is, I am going to find the circumference of the circle. The circumference of the circle is what? 2 pi r. When r is equal to 1, I get the circumference as 2 pi. That means the entire rotation gives you what? 2 pi. I can say that one revolution here is 2 pi. One revolution here is 2 pi. So, one revolution is 360 as well as one revolution is 2 pi. Now, here the value of pi to be taken as 22 by 7. To convert into what? Degree measure. Okay. For the time being, I am keeping pi value as 22 by 7. Now, comparing these two equations, I can say that 360 degree is equal to 2 pi radian. Right? 2 pi radian. So, what is 1 degree? 1 degree is equal to 2 pi by 360. That is pi by 180 what? 180 radian. So, 1 degree is equal to pi by 180 radian. Whereas, what is 1 radian? 1 radian is equal to 360 degree by 2 pi. 2 goes here 180 times. So, this is 180 by pi into pi degree. 180 by pi degree. So, 1 degree is equal to pi by 180 and 1 radian is equal to 180 by pi. So, this is something that you have to learn from this particular topic. Now, we are going to discuss on how to convert the degree measure into the radian measure and the radian measure into degree measure. Now, further I move into the conversion of degree to radian and radian to degree. Let's discuss on certain degree measures which you already know. Let us convert those degree measures into radian and see. You are familiar with degree measure 30 degree, 45 degree, 60 degree, right? 180 degree. Okay. Now, 360 degree, now I have discussed. Now, how many radians is that? 2 pi radians. Okay. So, now let's see how to convert 30 degree into radian. So, 30 degree into radian means what? Multiply by pi by 180. So, in radian measure, pi remains as it is. So, 3 goes here, how many times? 30 goes here. How many times? 6. 6 times. So that gives you pi by 6. So I can write that the radian measure corresponding to this is pi by 6. Now coming to 45. 45 into pi by 180. 45 into pi by 180 gives you what? 45 degree. Right? Pi by 180 gives you pi by 4. This is pi by 4. That gives me pi by 4. So this value is pi by 4. Then comes to 60 degree. 60 into pi by 180. 60 into pi by 180 gives you what? Pi by 3. So the radian measure corresponding to 60 is pi by 3. Now coming to 180 degree. 180 degree means what? 180 into pi by 180 degree. So 180 and 180 cancels to give you value pi radian. So these are the measures, corresponding measures of radians. So here in this chapter we will be hardly using degree measure, but most of the time we will be using what? Radian measure only. So this is how you convert the degree measure into radian measure. So the degree measures which you already know, which you are familiar with, 30, 45, 60, only till 60 you are familiar with. Then 90 is also there. 90 degree means what? 90 degree gives what? 90 into pi by 180. 90 into pi by 180, that is pi by 2. So the radian measure corresponding to 90 degree is pi by 2. Okay, so these are the various degree measures converted to radian measure which we will be using frequently in this chapter. Now let's move on to the problem session. Okay, to convert degree into radian and vice versa. Now let's see a problem. It is to convert the degree measure into radian measure. Here I have 40 degree 20 minutes. 40 degree 20 minutes. I can write this as 40 and 20 by 60 degree. Right? 20 by 60 degree. Now 20 by 60 degree, if you look at this, gives me 1 by 3. That is 41 by 3. This is 40 into 3 is 120. 120 plus 1, 121. 121 by 3 degree. 121 by 3 degree. Now to convert this into radian measure. To convert this into radian measure, I know that 1 radian is equal to pi by 180, right? So much degree is equal to what? Into pi by 180 radian. That gives me what? 121 pi by 540 pi. 121 pi by 540. So much what? Radian. So whenever you write in radian measure, you will have a pi with it. Okay, you will have a pi value with it. Am I clear? Now let's see how to convert a radian measure into a degree measure. That is to convert. Suppose I take a 2 by 3 pi radian into degree. So 2 by 3 pi radian. It is in radian measure. When I convert into degree measure, how will I convert a radian measure into degree measure? Multiplied by 180 by pi. Isn't it? 180 by pi. So pi and pi cancel. 3 goes here how many times? 60 times. Right? That gives me 120 degree. This is how I convert a radian measure into degree measure. Okay, we shall do one more problem to see how to convert the degree measure into radian measure. Okay, this I took a very simple one. Let's see how to convert one more degree measure into the radian measure into degree measure. Now, let's see how to convert 6 radian into degree measure. 6 radian into degree measure. So, 6 radian is same as 6 into 180 by pi degree. 180 by pi degree. Now this is equal to 6 into 180 by pi. I'll write it as 22 by 7. So whenever I simplify for pi to convert into degree, I substitute for pi as 22 by 7. In the former question, the other question, you know how did I write? I wrote pi as it is because I had a pi in the measure. So pi and pi cancel. So here I get it like this. So 6 into 180 by 22 by 7, that is 6 into 180 into 7 by 22. Now 2 goes here thrice, 2 goes here 11 times. Now that gives me 3780 divided by 11. Okay, 3780 divided by 11. Now when I divide this, I get the quotient to be 343 and remainder what I am going to get is 7 by 11. So I take this as degree and I multiply this by 60 so that I'll get the next section, that is the minutes. So what do I get? 343 degree into 420 by 11 minutes. By 11 minutes. So 420 divided by 11. I get this as 343 degree. When I divide this, I'll get the quotient to be 38 minutes. Sorry, this is minutes. This is seconds. 38 minutes, and the remaining will be 2 by 11 seconds. 2 by 11 seconds. So seconds meaning what? I need to multiply this by 60 to put it as in seconds. So what do I get? 343 degree, 38 minutes and 120 by 11 seconds. 120 by 11 seconds. I can write this as 343 degree, 38 minutes and 120 by 11. I will write it as 11 seconds approximately. I believe that how I wrote this is clear to you. That 3780 divided by 11. What do I get? 3 is 33, 48, 4 is 44, 40. So 3, 33, balance of 7. So I'll write this as 343 into 7 by 11. That is how I got this as 343 into 7 by 11. But 7 by 11 I am writing it into minutes. So I multiply it by 6. So 6 7s 42, 0 divide by 11 again. So again when I divide, I get the quotient to be 38, remainder to be 2. So I'll write it as 38 minutes and 2 by 11 into 60 seconds. So that remainder part or the fractional part here I am putting it into seconds form. So ultimately I'll get it as 343 degree, 38 minutes and 11 seconds. Okay, so this is how I convert 6 radian into degree. I hope this is clear. Now let's see another question. Find the radius of the circle with central angle 60 degree and arc of length 37.4 centimeter. So now we know that the formula of finding the angle theta is equal to L by R. Now this theta must be in what? Radian. Isn't it? But here the theta value is given as 60 degree. So let me convert this theta, which is 60 degree, into radian. So converting into radian, I multiply this by 180. Right? So 60 goes here how many times? 3 times, and I get it as pi by 3. Okay? Pi by 3 radian. Now coming back. So pi by 3 is equal to, the arc length is given to be 37.4 by the radius is what I need to find, right? So this implies radius is equal to 37.4 by pi into 3. So pi to be taken as 22 by 7. We know that. So that is 37.4 into 3 into 22 by 7 is 7 by 22. When you simplify this, you get the value to be 35.7 centimeters. So this gives you what? The radius. The radius measure is to be 35.7.